All right, so today we're going to take a deep dive into the world of gemology, specifically how gemologists actually identify gemstones using a tool called a refractometer.
Yeah, we're going to be looking at a tutorial from the YouTube channel, Gemology for Schmucks.
For schmucks, okay.
But don't let that name fool you. It's actually quite detailed.
Yeah,
And we're going to try to give you the basics so that you can really appreciate the science behind identifying these precious stones.
even if you're not planning on becoming a gemologist or anything like that, it's kind of cool to know, to have a little peek behind the curtain, so to speak.
Yeah, I'm fascinated by this stuff. So at the heart of it all is the refractometer. And it looks a little complicated, but it's not too bad once you break it down.
Yeah. So what are the basic components that we need to understand here?
Well, first you have the body of the refractometer itself, and the key part on top is the glass hemicylinder.
Glass hemicylinder.
And that's where the magic happens. That's where the light bending or refraction happens.
Oh, that's where the name comes
Yeah,
from, the
yeah.
refraction.
Exactly.
Yeah.
And then you got your light source. And you really want to use a full spectrum light, like a mag light, for optimal results.
But I noticed in the video they said that a phone light will work in a pinch.
You can use a phone light, yeah.
Why do we need that full spectrum?
So full spectrum light's going to give you a consistent range of wavelengths, which is really important when you're measuring refractive index.
Oh.
Because, different wavelengths of light are going to bend differently when they enter a gemstone, so you want to have that consistency.
Right, so it's all about accuracy then. Okay.
Exactly. And then there's this refractometer liquid.
Yeah, the smelly stuff.
Yeah, it's pretty potent.
Yeah.
You got to handle it carefully.
Yeah, I bet. So this liquid, it has like a maximum refractive index reading, right? What is that?
Yeah, so the one they're using in the video has a maximum reading of 1.80.
1.80, okay. What kind of gemstones would fall into that range?
That covers a lot of your common gemstones,
Yeah.
things like quartz and topaz and many types of beryl, like emerald and aquamarine.
Okay, so pretty much, the usual suspects, I guess.
Yeah, exactly. So, but if you had something with a refractive index higher than 1.8, you might need a different method or a different liquid altogether.
Oh, interesting. So that's something to keep in mind. And then we also have a polarizing filter and a little magnifying lens. What are those for?
So the polarizing filter, that's really key for testing birefringence. We'll get into what that means in a bit.
Okay, right.
And the lens, well, that just helps you magnify the scale inside the refractometer.
Gotcha. It makes it easier to see those little numbers. And of course, there's the lid.
Yeah, the lid.
Seems basic, but it's important, right?
Very important. You want to block out any stray light that could mess up your leadings.
Right. Keep things nice and controlled. So now we've got all the pieces laid out. How do we actually use this thing to test a faceted gemstone?
Okay, so the first step is to put a little drop of that refractometer liquid onto the metal part of the device. And I mean a little drop, like just a tiny amount.
Yeah, they emphasized that in the video, didn't they?
They did. You just need enough to create contact between the gemstone and the hemicylinder. Any more than that, and you risk getting messy and inaccurate readings.
Makes sense. Less is more in this case. And after that, we need to prep the gemstone itself.
Right. And you want to choose a facet that's well polished. That's really crucial.
Why is that so important?
Well, you need that smooth, even surface so the light can enter the gemstone cleanly, and any scratches or imperfections can scatter the light, which messes up the readings.
Makes sense. So we've got our tiny drop of liquid, nice polished facet on the gemstone. What's next?
You gently place the gemstone onto that liquid.
I remember them using the word scoot in the video.
Yeah, you kind of scoot it on there. You don't want to press down too hard and risk scratching the hemicylinder.
So it's all about being super gentle, like handling a delicate little treasure, I guess.
Exactly. So once the stone is in place, you look through the eyepiece, and you'll see a scale there with numbers. Usually it goes from 1.30 at the top to 1.80 at the bottom.
Okay, and what are we looking for on this scale?
You're looking for something called the dividing line.
The dividing line, okay.
Yeah, and you might have to move your head a bit until you see it. It's like a distinct line where the view changes from light to dark.
Oh, I see.
Once you find that line, you want to keep your head still. And then you can add the magnifying lens to get a closer look at where that line falls on the scale.
Right, and that gives us the refractive index reading. But then we bring in the polarizing filter, right?
Exactly. That's where we start testing for birefringence.
So remind me, what is birefringence again?
So basically, birefringence happens when light enters a gemstone and get split into two rays. And those two rays travel at different speeds. So they have slightly different refractive indices.
And that's what the polarizing filter helps us see.
Right. So you put the filter on and take your first reading, then you rotate the filter.
Okay. And what are we looking for when we rotate it?
You're watching to see if that dividing line jumps or shifts as you turn the filter.
And if it does?
That means the gemstone is doubly refractive and you need to take a second reading.
Double refraction. Okay.
Boom.
So we get 2 readings. And what do we do with those?
Well, the video mentions that you need to rotate the gemstone itself too.
Rotate the gemstone. Why do we do that?
Because with these doubly refractive gemstones, the amount of light splitting isn't the same in every direction.
Oh, I see.
There's this thing called the optic axis, or C-axis, and if light travels along that axis, it won't split at all.
So by rotating the stone, we're basically trying to find the maximum split, I guess.
Exactly. You want to find the orientation where the difference between those two refractive indices is the greatest.
So we keep turning, taking readings, and then how do we determine the actual birefringence value?
You just calculate the difference between the highest and the lowest readings you got. That range is the birefringence.
Oh, okay.
And this value, along with the average refractive index, is super important for identifying the gemstone.
So it's like a fingerprint for the stone.
Exactly. And once you've got all your readings, you got to be careful removing the gemstone.
Right. No scratching that hemicylinder.
Yeah.
And then clean everything up.
Yeah. Clean the gemstone, clean the hemicylinder, everything nice and tidy.
But what happens if, when we look through the refractometer, we don't see that dividing line at all?
That's when you might have a gemstone that's over the limit, or OTL.
Okay, OTL.
So remember the refractometer liquid we talked about? It has a maximum refractive index of 1.80.
Right.
If a gemstone has a refractive index higher than that, well, the light bends so much that you won't see that dividing line within the instrument's range.
So it's basically like off the charts. Too bright, too sparkly to measure.
Right. And that's where visual inspection comes in handy. Gemstones with a very high refractive index tend to have this intense, brilliant luster.
So you can kind of get a clue even before you use the refractometer.
Exactly. Okay, so that's all well and good for faceted gemstones, but what about cabochons? Those smoothly rounded stones.
Yeah, how do we test those?
Well, for cabochons, we use something called a spot test because you can't get that same flat contact with the hemicylinder.
Right, because of the curved surface.
Yeah.
So how does the spot test work?
It's similar, but there are some key differences. First, you still want to find the area on the cabochon with the best polish.
Okay.
And then you use the smallest amount of refractometer liquid possible.
Even less than with a faceted stone.
Even less, yeah. Because too much liquid can distort the light path.
Oh, that makes sense.
So you just want to create a tiny dot of contact between the stone and the hemicylinder. They said in the video, like, the size of 2 or 3 of those smallest dash marks on the ruler.
Wow, that's tiny.
It is. And you have to kind of tap the cabochon on the refractometer to get that tiny dot.
Yeah, interesting technique. So then how do you read the refractive index?
You find that little dot of light through the eyepiece, and you take the middle value of that dot on the scale.
Just one reading then?
Yeah, just one. And you can't test birefringence with cabochons using this method.
Oh, okay.
You'd need a different instrument for that.
So the spot test gives you some info, but not the full picture.
Exactly. Now, the video also stressed that using a refractometer is a perishable skill. You got to practice to get it right.
I can imagine. Seems like there are a lot of subtle nuances.
There are. It's all about accurately locating that dividing line, interpreting the readings, and that takes time and repetition.
Like anything, practice makes perfect. And speaking of practice, what about choosing a refractometer? Are there different models for, different levels of experience?
Yeah, there are lots of options out there. You've got your basic entry-level models all the way up to those fancy professional ones.
So if you're just starting out, you don't need to break the bank.
Not at all. The video mentions that if you're mainly testing faceted stones, a cheaper model with a built-in light can be perfectly good.
But for those who want more flexibility, maybe to test birefringence, what would you recommend?
Well, the host of the video really liked the GemPro. It's not as expensive as some of the big-name brands, but it still has all the features you need.
So good value for money then.
Yeah, and it's made in the USA, which is a nice bonus.
Right. So lots of options to choose from. But like you said, practice is key, no matter what tool you're using.
Absolutely. You got to develop that eye for detail, that feel for the instrument.
So to wrap things up, it seems like the refractometer is a pretty fundamental tool for gemologists.
It is, yeah. You can measure the refractive index and, for faceted stones, the birefringence.
And those are like the key properties for identifying gemstones.
Right. And it all comes down to careful preparation, using that liquid precisely, and knowing how to read the scale. And we learned that there are different techniques for faceted stones and cabochons.
So much to learn about these precious stones.
It is, and it's fascinating, right?
It is. Even if you're not going to become a professional gemologist, just having this peek behind the curtain, seeing the science that goes into identifying these beautiful objects, it's pretty cool.
Absolutely. It makes you appreciate the complexity and the hidden knowledge that goes into so many things we take for granted.
Yeah. And it makes you think, what other everyday things have this hidden layer of expertise and intricate processes behind them? I mean, maybe next time we see a gemstone, we won't just see a shiny object. We'll see the science, the history, the whole story.
Exactly. And maybe we'll start to notice that hidden complexity in all sorts of things around us.
Food for thought.
Definitely.
Well, this has been another fascinating deep dive. Thanks for joining me today.
My
Hey there,
pleasure,
fellow
as
movie
always.
enthusiasts. Welcome back to our channel, where we dive into the fascinating world of movies and TV. Today, we're excited to share with you a step-by-step guide on using a refractometer for gem identification. Gem identification is a crucial skill for any aspiring gemologist, and a refractometer is a handy tool that can help you accurately determine the refractive index of a gemstone. By understanding the refractive index, you can identify the gemstone more precisely and confidently. So, let's dive into this intriguing topic and learn how to use a refractometer for gem identification. We'll cover everything from calibrating the refractometer to interpreting the results. Trust us, once you master this technique, you'll be well on your way to becoming a gem identification pro. This guide provides a step-by-step process for using a refractometer to identify gemstones. Designed for both aspiring gemologists and enthusiasts, this document covers everything from preparation to testing techniques, helping users effectively operate this essential tool. Before using the refractometer, previous episode recap. In the prior episode, The Truth About Bling, we introduced the refractometer and discussed the importance of surface luster in gem identification, identifying a gemstone for testing. Choose a faceted or cabochon gemstone that you wish to identify, ensuring proper preparation for faceted stones. Locate a polished facet. For cabochons, find a well-polished area, gathering necessary materials you will need. A refractometer liquid maximum Re of 1.8, a full spectrum light source. Steps for spot testing cabochon gemstones. 1. Identifying a polished area. Find the most polished area on the cabochon. 2. Applying minimal refractometer liquid. Place a small dot of liquid on the metal part of the refractometer. 3. Applying the gemstone. Dip the polished area of the cabochon in the liquid and leave a tiny dot of liquid on the stone. 4. Placing on the hemicylinder. Position the cabochon on the hemicylinder with the liquid dot. 5. Looking for the dot. Locate the small illuminated dot through the eyepiece. 6. Taking the reading. Read and record the Re number where the dot appears. 7. Note on birefringence. Birefringence cannot be tested on cabochons with a standard refractometer. 8. Removing and cleaning. Follow the same careful removal and cleaning process as for faceted stones, identifying over the limit auto stones. 1. Observing the view. If a gemstone's Re exceeds the refractometer limit above 180, the view will flood with red or rainbow colors. 2. Lack of dividing line. No clear dark and light dividing line will be visible. 3. Recording auto. Document the stone as auto over the limit. After testing, importance of practice. Regular practice is crucial, as using a refractometer is a perishable skill. Different refractometer models. Various models exist. Look for features like a removable lens and polarizing filter to expand testing capabilities. Recommendation of GemPro refractometer. The narrator prefers the GemPro refractometer and provides information on contacting the US-based maker. Concluding remarks. The narrator encourages aspiring gemologists to continue practicing their skills. Cast of characters. The narrator, a knowledgeable host of the Gemology for Schmucks video series, providing accessible and practical tutorials. The audience, aspiring gemologists and gemstone enthusiasts, encouraged to engage with the content. The professors, mentioned as using cell phone lights as a light source, indicating the narrator's formal gemological education. The maker of the GemPro refractometer, A US-based manufacturer with whom the narrator has a positive relationship, big names makers of most famous refractometers. Unnamed manufacturers of high-end refractometers implied to be more expensive but not necessarily superior. Conclusion. By following these steps, gem enthusiasts and professionals alike can accurately determine a gemstone's refractive index and birefringence, making gem identification more precise and efficient.